Today we're going to talk about the slopes of secant and tangent lines. Now this is kind of a review because it's things that we've talked about before. We're just kind of putting it all together in one lesson just to kind of help things be a little bit easier to do. Okay? How many of you have ever seen the game show Deal or No Deal? Quite a few of you have. I've seen probably one episode. I know how the game show works. But today is kind of similar to that. Today we're going to call calculus or no calculus. Because some of the problems need to be done with calculus and some of them need... So, on your paper, please write 2 columns. Calculus, and then over here put no calculus. So instead of deal or no deal, it's calculus or no calculus. Now, what I'm going to do is give you key phrases that you need to look for within the word problems that you're going to be doing today. If you see the phrases that fall under the calculus column, you're going to use calculus to solve it. If you see the phrases that fall under the no calculus column, you're going to use not calculus methods to solve them. No, but this is stuff that you've already seen before, so not in this format, but some of these formulas you might see. And I'll bring those up. Okay, before I start writing, let me ask you this question. If I said the phrase slope of a tangent line, do you think that would be a calculus or a no calculus?
Calculus.
It is calculus because tangent lines are dealing with calculus. So slope of a tangent line is, and slope of a secant line would be no calculus. Slope of a tangent line is calculus. Slope of a secant line is no calculus. Okay? The next 2 phrases I'm going to tell you we have already talked about before. Average rate of change and instantaneous rate of change. Do you think average rate of change is calculus or no calculus?
No calculus.
That is no calculus. So put average rate of change right here. Under no calculus. And then under calculus, we're going to put instantaneous rate of change. Because we have talked about those before. Okay. The next 2 are going to be pretty obvious where they go. Where do you think instantaneous velocity would go? Calculus, because it's instantaneous. Instantaneous velocity, because velocity is rate of change. And underneath that, you need to also write at bracket A bracket. That is another key right there that it's calculus because they will give you only 1 point instead of 2 points. So when you're doing average velocity, which goes under no calculus, they will also say on the interval from bracket A comma B bracket. They'll say from 2 to 5, from 1 to 4, something like that. So if they give you 2 x values, that's going to be a no calculus problem. Okay? Now, even though these all are talking about what seem to be slightly different things, they're all done in the same manner. So I'm going to draw a special little arrow for both of these. This is the process you're going to use to do these problems every time. When you do calculus and you're asked to find a slope of a tangent line, what do you do to the equation? Do you remember? What have we been doing for the last week and a half? Derivatives. So it's going to be the derivative, f prime, at the point A. So it's f prime of A. Now for the no calculus, we're going to use a difference quotient because that's how we find average values or secant line slopes. Do you remember the formula? Now this will be on the test. Do you remember the formula using A and B that looks like a difference quotient?
F of B.
F of B minus what? F of A over B minus A. That one. That's what you use when you're doing a no calculus problem. Michelle?
Can you do all those? You always put the big number first.
You really should. It doesn't matter as long as you're consistent, but I like it better when you do. Good question. Okay, so let's take an example. This is what the homework problems are going to look like. They're going to give you a function, f of x equals 2x cubed minus 6x squared plus 5. And then they're going to ask you some questions about it. So let me move this up a little bit.
This is on the test tomorrow, is this?
This is not, no. Find the slope of the secant line between x equals 1 and x equals 3. That's the first question. Find the slope of the secant line between x equals 1 and x equals 3. Yeah, that's my and symbol. So is this a calculus or no calculus question? No calculus. Okay, two reasons why. Somebody give me one of them. Secant line is the first one, and the second one is, there's 2 points. They give you 2 points. Exactly. So I'm going to write NC for no calculus for this problem. You don't have to do that. I'm just doing it for my own, for something for you to refer back in the notes. So if it's no calculus, you use the difference quotient here. So it's going to be f of 3 minus f of 1, 3 minus 1. That's how you find the slope of the secant line. Okay? So now I need to do some math. Let's figure out what f of 3 is. F of 3 would be 3 to the third is 27 times 2 is what? 54 minus 3 squared is 9 times 6 is 54 plus 5. That's easy. That's 5. You need to be able to do this math without a calculator, because you won't have a calculator if you do something like this on a future quiz or test. F of 1. So it'd be just 2 minus 6 plus 5, which is what? 2 plus 5 is 7, minus 6 is 1. So minus 1 over 3 minus 1.
4 over 2.
4 over 2, which is 2. Slope of the secant line is 2. And we've answered the question. Okay? Part B. Find the slope of the tangent line at x equals 1. Find the slope of the tangent line at x equals 1.
Will it ever give you one or 2 points if you're given a tangent?
No, ma'am, it will not. Okay, calculus or no calculus? This is calculus. So I'm going to take the derivative of this function that I was given. What's the derivative of the first term? Bless you. 6x squared minus 12x. And what about the 5? That's 0. So we just leave that off. And then it says f prime of a. So whatever the a value is, in this case it's 1. We substitute it in. F prime of 1 equals 6 minus 12, which is negative 6. So there's the slope of the tangent line at 1. Okay? Now, part C, I'm going to squeeze it at the bottom because I can get it in there because it fits with A and B. Write the equation of the tangent line at x equals 1. Write the equation of the tangent line at x equals 1. So, what do you need to write the equation of a tangent line? We just did this on the quick quiz.
Y minus 1.
Okay, we're going to do the y minus y1. Exactly. So I can go ahead and write that down. That's where I'm going. Equals mx minus x1. So I need to know the m.
Negative 6.
And that's negative 6. And that's the answer from part B, right? So this is from part B. And then we need a point.
0, 5.
Not in this case. Okay, it has to be the point where it's tangent.
Oh.
What did they tell me the x coordinate? What do they tell me? They tell me that it's 1. So at x equals 1, it has to be at 1. So how do I find the y value?
Plug 1 into the main equation.
Plug 1 into the original equation, which I have off the screen right there. Let's move it down a little bit. So 2 minus 6, I already did that right here. 2 minus 6 plus 5 is 1, so that's a 1 also. This is from part A. From part A. Okay, now, take the information you have right here, plug it in, y minus 1 equals negative 6, parentheses, x minus 1, and stop right there. You're finished. When you're doing free response questions like this, here, when you're asked to do something like write the equation of a line, and here is why. When you do free response questions, you don't lose points, you gain points. There's a total of 9 points to be gained. You gain a point for everything that you do that I'm looking for to work the problem. So, writing the equation of the line, 9 points for all 3 parts. So, writing the equation of the line correctly is a point. But if you take that line and you try to solve for y and you mess up and say, oh, this is my final answer, and it's the wrong final answer, you lose the point you just got up here. You see what I'm saying? So you ungain the point that you had. That's the only way you can lose a point. So it's best to stop right here and not mess up the algebra cleaning it up, unless you're trying to match it to a multiple choice question. Does that make sense? Okay. Any questions on this problem that I just did? Okay, I have one more sample to show you. So I need to go to a new sheet of paper. This one says S of t equals 5t squared minus 20t plus 4. And you may be thinking, what in the world is S? S is a variable that Physics C people are probably already familiar with. Am I right? S of t? Okay. If you aren't, you are going to be. S represents the position of an object. In this case, it's in miles. After t hours of travel. So the S is the position after t hours in this specific instance. Okay? If you take the derivative of position, do you know what that equation is? It has its own special name, not just S prime.
Wow.
It is velocity. It is velocity. Okay, so let me show you. It's a good guess.
Oh, you
Okay.
can guess.
No, I knew you knew it. Find the average.
I don't know, it's funny.
Find the average velocity from t equals 0 to t equals 5. First question. Find the average velocity from t equals 0 to t equals 5.
That's no calculus, right?
Correct. How did you know that?
Average velocity.
Because you said average.
Average is no calculus, and it's 2 points. That's another reason. Okay? So to do this, this is no calculus. So I'm going to use S of 5 minus S of 0 over 5 minus 0. S of 5, I'm going to have to do a little bit of math, too, to find it. So S of 5 would be 5 squared is 25 times 5 is 125 minus 20 times 5 is 100 plus 4. So 125 minus 100 is 25 plus 4 is 29. There's the first one. Minus, what is S of 0? That's 4. You just go up here, put zeros in for the t's. Over 5 minus 0. So now we have 25 over 5, which is 5. Now, because we're dealing with velocity, I need a unit of measure. Not in this case. Miles per hour. It tells me up here it's miles an hour, so it's miles per hour. That's the average velocity.
Do we write MPH?
I will accept it either way. Good question. MPH is just as fine as miles over hours. Okay? Any questions on that one before I do part B? No? Find the instantaneous velocity at t equals 3. Find the instantaneous velocity at t equals 3. Okay.
Calculus.
This is calculus. Now, this also is why the derivative of the position is the velocity, because what am I going to do? I'm going to take the derivative of s. So s prime of t equals, come back up here. What's the derivative going to be? 10t minus 20. Okay. Now what do I do?
Plug it in.
Plug in 3 to the derivative I just 3 equals 30 minus 20 is 10. Okay? But this needs a label also. Bless you. What label does this one need? It's a velocity also. So if it's a velocity just like this one is, it's going to have the same label, miles per hour. So now with calculus, we can find out how fast something is moving at a specific instant in time, instead of just trying to figure out what the average is going to be. We can find it in an instant. At time 3, when it's 3 hours into its trip, it's going exactly 10 miles an hour. All right? Any questions? I'm finished.